Welcome to Study Loop.
This is the answer to Chapter 22, problem number 24 from the Smith Organic Chemistry textbook. And this problem is essentially just the base catalyzed hydrolysis of an amide. It is a cyclic amide, which are also known as lactams. But still, it's just the base catalyzed hydrolysis of a lactam, or a cyclic amide. And so remember, continuing the theme of this chapter, chapter 22, carboxylic acid derivatives, all the action is going to happen at the carbonyl carbon. So what we see here is the hydroxide ion is going to attack that electrophilic carbonyl carbon. The electrons from one of the two bonds in the carbon-oxygen double bond, those two electrons will kick up onto the oxygen. So now we have the hydroxide ion has added to the carbonyl carbon. The oxygen that was formerly double bonded to the carbon is now single bonded to the carbon and has a negative charge on it. And the carbon has four bonds to four different things. So we call this a tetrahedral intermediate. Because the carbon has four bonds. Carbon always has four bonds. The carbon has bonds to four different things, whereas previously it had two unique bonds and a double bond. And so the next step, as always, is this oxygen with the extra lone pair. That extra lone pair will add back in to reform the double bond. The weakest bond will break. In this case, it's the carbon-nitrogen bond. So those electrons will revert to the nitrogen. So this will open our ring up. The nitrogen now has a negative charge on it and an extra lone pair. And the way that this mechanism is drawn, the nitrogen will pluck this hydrogen from the oxygen here, and the oxygen-hydrogen bond electrons will revert to the oxygen. And this makes sense in the context of this mechanism, right? Because it is basic conditions. So we know that we're going to end with the benzoate ion rather than, I apologize, not a benzoate ion. We know that we're going to end with a carboxylate ion rather than a protonated carboxylic acid because it is basic conditions. And so that's what I've drawn here. And then here at the end, we have our carboxylate ion. And remember, if we were to switch media here and put it in acidic conditions instead, this would become protonated. You may see this drawn sometimes as the base that's still in the solution, the hydroxide ion, will take this proton, and the nitrogen will get a proton from the water that's floating around in the solution. That's acceptable as well. This is just sort of more concerted and shows these things happening as a single step. And again, we do want to end with the carboxylate ion because it is basic conditions. And so that is the stepwise mechanism for the base catalyzed hydrolysis of this lactam. And that's the answer to problem number 24.